Nice easy lesson here, triangle mid-segment theorem. We're going to first define what a mid-segment is. And the mid-segment of a triangle is a line that joins the midpoints of two sides of a triangle. So right there, so that's just by definition. So basically what we're going to do here is we're going to construct the mid-segment of the triangle below. And again, mid-segment is a line segment that joins the midpoints of two sides of a triangle or trapezoid. For the moment, we will work with a triangle. So estimate the midpoints of AB and AC. So we're going to estimate. Again, they actually said construct, but I'm not going to construct it. We're just going to estimate it, okay? So you could construct the midpoint. We did construct the midpoint earlier in the year. So I'm just going to estimate. Does that look about where the midpoint is? It does kind of look like the midpoint of each one, right? This might be a little bit high, maybe about right there, okay, is the midpoint. So what we're going to do is we're just going to connect those midpoints, and that right there is a mid-segment. That's a mid-segment, okay? Draw mid-segment XY. So XY. All right? So now, what we want to do first is try to learn what the triangle mid-segment does. There's a couple relationships we want to learn here. First, compare these two angles. Compare angle AXY, that's this angle here, with ABC. Okay? Do those angles, what do they look like? Do they look congruent? They sure do, right? Now compare AYX, this guy, with ACB right here. Do those angles look congruent? Okay, what would you guess is the relationship between these two pairs of angles? What is the reasoning? Okay, they look congruent. Okay, they look congruent, and that means, and they are. It turns out that they are. I mean, we could do constructions and measure it and take a protractor and measure the angle and everything. We could do that. It turns out that they are congruent. Okay, and if I can give you a protractor in class tomorrow, we can measure it out to tell. We'd have to actually construct it though. So it turns out they are congruent, and if you remember from earlier in the year, when you have congruent angles like this, these are called corresponding angles. Okay. When you have corresponding angles congruent, what does that mean? That means that the line so if I have two lines cut by a transversal, right, and the corresponding angles are congruent. See, it's the exact same thing. Look at that. Two parallel lines cut by a transversal. When you have congruent corresponding angles, that means the lines are parallel. So what that tells us is, as long as these angles are congruent, which they are, the segments here are going to be parallel. So that means that the mid-segment is parallel to the third side. The mid-segment of a triangle is parallel to the third side, and that's what we have right here. Okay, and that's what I boxed up here. The mid-segment of a triangle is parallel to the third side of the triangle and half the length of the third side. Okay, so how do I know it's half the length of the third side? That's just by definition. It turns out that this length right here is half of this. It's half of this. So if this is 4 and this is 8, all right? If this is 8, this is 4. If this is 4, this is 8. And you could cut this up 4 and 4. Whatever it may be, okay? So we're going to use that right there to answer these questions here. Find X, okay, so here's a mid-segment. Here's a mid-segment. This is 30, so the mid-segment must be half of that, which is 15. The perimeter of triangle ABC now I want to find. Okay, so now what do? Well, I know that since this is a midpoint, right, if this is 9, this must be 9. And this is a midpoint, so if this is 10, this must be 10, right? Mid-segment cuts into two equal parts, and this is 30. So now I want to find the perimeter of triangle ABC. Well, what's this length right here, plus this length right here, plus this length right here? So I just got to add all the sides of the triangle up, triangle A, B, C. Okay, so this is 18, 9 and 9. This is 30. And this is 10 and 10, so 20. 18 plus 30 plus 20. 50 plus 18 is 68. So the perimeter would be 68. This one here, find x and y. Okay, so this x is the corresponding angle for 50. So if that's 50, this must be 50. And then this angle here is the third angle of, look at the big triangle here. See the big triangle? Oh, I just messed that up. There's that big triangle there. Okay. So I'm just going to redraw that, the green triangle there. Okay. So if this is 50 and this is 60, that's 110, right? That's 110, so this must be 70 because the three angles of a triangle have to add up to 180. So that's going to be 70 degrees right there. All right, exercise 2. So what we have now is we have all three midpoints marked already on this big triangle RST. So what we're going to do is we're going to connect the midpoints, make 3 mid segments. So sometimes you're going to see this or be asked to do this and make all 3 mid segments of the triangle. Okay. So what we've done now, and what we want to do now is we want to mark congruent sides. So let's look at it this way. I'm actually going to change colors. I'm going to go green here, red here, and then blue here. Okay? Because this is the mid segment of this here. So this is congruent to this, right? So we're going to mark those congruent. Those are all congruent. So I'm going to put a little hash mark on there. And then this is the mid segment parallel to this. So this and this are going to be the same. Boom, boom. We're going to put 2 hash marks on all those. Those are all the same length, right? Remember, the mid segment is half of the parallel side, so those pieces must be equal. And then for the green, so this will be the same as this one and this one. So boom, 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 boom. Now take a look at what we have here. How many triangles do we have? We have 4 triangles, okay? And each of those triangles has a blue, a red, and a green side. Look at that. Look at that. Blue, green, red. Red, green, blue. Red, green, blue. All these, and then of course the middle one, right? They all have a red, a green, and a blue. They all have a single, a double, and a triple hash mark. That means that all these triangles are congruent by side, side, side. So what conclusion can you draw about all 4 triangles within RST? All 4 triangles are congruent by side, side, side. Okay? State the appropriate correspondences among the 4 triangles within triangle RST. So it's going to be XY. XY is congruent to SZ is congruent to ZT, and so on. So we're going to actually skip this one because I don't really care about that. State a correspondence between triangle RST and any one of the 4 small triangles. Okay, so you can do any kind of correspondence there you want. So we could say, all right, RST is the big triangle, right? So we could say RX is congruent to YZ. Okay, there's a correspondence. All right, and then I want to go further than that. I want to go further. You can put that down. You don't have to erase it. I want to go further than that though, and I want to say, how does triangle RST compare to the 4 smaller triangles? So if the RST is the big triangle, how does the big triangle compare to one of the little triangles? Well, if 4 of those little triangles fit inside the big triangle, then each of those little triangles is 1/4 of the big triangle. So therefore, triangle RST is 4 times larger than each of the smaller triangles. Each of the smaller triangles. All right. Example 2. Given triangle ABC with midsegments GH, HI, and GI, find X. Okay, so this is 61, so we got 61 here. This is 40, so this is going to be 40. See the corresponding angles? Boom, boom. Okay, so if this is, see, this is 61 here, so we have, this is 61 right here. And if this is 40, this must be 40. So what I'm going to do is go off of this right here. I have a 180. I have a 180, and if I have 61 plus 40, that is 101, and the X is the leftover because those three angles got to add up to 180. Remember we did that earlier in the year? So 180 minus 101, and you're going to get 79. So angle X must be 79 degrees. Okay, so I'll see you in class tomorrow to practice on the triangle midsegment theorem.